Hello, I think everything's okay. Do you hear me right now? Let's see. I think I clicked on the wrong button a second ago. Is everything okay? Do you hear me? Do you see the desktop? Anybody? Is it working? Oh, okay. All right, great. Thanks. Okay. So you can hear me and you see the desktop and you hear me okay. All right. All right. Okay. Okay. So today we're going to start talking about this idea of objects, classes and objects. Now, actually, we've been talking about objects all through the semester, and now we're going to start talking about writing our own. So let me start by going to the Java visualizer, and just let me remind you a little bit real quickly about what we mean by objects. Okay, so an example of an object is a string. So I can say string s equals uh, new string Hello. Okay, so I have that creates, remember, we've said this a lot and it's real important. It does three things. It creates a new string objects. Okay, so it actually creates in the when the picture we'll look at a second ago, it creates the object that's on the right side of the picture. But then it gives that object a name. This is the name, and not all objects have to have names. In a second, I'll show you that an object doesn't have to have a name. Okay, so that creates the name for the object, and then it makes that name refer. It becomes a what we call a reference. It refers to the object. So if you draw a picture real quick, whoops, I have to change Dr. Java. Or I have to change the visualizer to drawing the correct picture. Remember, it wants to draw the picture simplified. There. See, you created that object, created that variable, made a reference to the object. Okay. Now, objects hold methods inside of them. So I can say to the string uh, to upper case. Okay. The dot means I'm calling a method on that object. Okay. And this method doesn't take any parameters. Okay. Now that method returns something. So I need to capture the return value. So I'll say string s2 equal. Now, this is a new reference variable, not a, and it happens to be pointing at a new string because this creates another string object. It takes that string object, we're calling a method on that string object, and we're creating another string object. See, we created a second string object. Okay, I can do something like, okay, there's another name, but I can make it a name for the second string object. Now I have three names, but I still only have three objects. So remember, we learned to keep track of the difference between an object and a name for the object. So I have two names now for that same object. Okay. And if I want to, another example is I could call a method s3 dot substring. Now this method takes parameters. I'll go between 2 and 5. Okay, that's going to be the substring from the third character up to the fifth, but not including the fifth. Well, from it'd be characters 2, 3, and 4. So in this string here, it'd be characters 0, 1, 2, 3, and 4. Okay, so it'd be characters 2, 3, and 4, LLO. But that also creates another object. So I'm going to let S3 be a name for that object. So S3 is going to stop pointing at S2, and S3 is going to point at this new string. Okay. there's S3 is pointing at that string right now. But when I call that method, I get another object, and I'm going to reuse the name S3 to point to that object. Okay. If I wanted to, I could have created another name here. And left S3 pointing where it was. Okay. 1, 2, 3, 4 names, 3 objects. And remember, like in homework assignments and exam questions, you have to learn to keep track of the difference between the names and the objects. Okay. So another example would be take S2 and set it equal to null. That makes it stop pointing at anything. Okay. Does it really change anything in my picture? Oh, it changes the picture a little bit, but I still have to, like, how many objects do I have? When I made S2 null, that object lost one of its names, but it's still there because it has a name. Okay. So I still have 3 names. I have 3 objects. I have 4 names and 3 objects. On the other hand, if I set S3 equal null, this is going to be kind of different than this S2 equals null. We'll see in a second. Okay. Now S2 equals null makes that arrow go away. Now S3 equals null makes that other arrow go away, but then that string will go away. See, now I'm down to only 2 strings. 4 names, 2 strings. 2 of the names don't name anything. Okay. Keeping track of names and objects. Okay, so this is the kind of thing this is what we've been doing so far. We've learned that we can create. I can reuse one of these names. I can create objects this way. New string by. Okay, so now I'm going to reuse one of my names to create a new string. Okay, so we can create. We can create objects. We can create names. We can assign the names to the objects. We can make the name stop being a name. We can't make names go away. We can make objects go away. But see, once we declare these variables, that's one important thing is you can't make a name go away. The only way the names go away is the program ends. Okay, names don't go away. Actually, the way they also go away is a method ends. If a name exists in a method, then the name goes away when the method ends. Variables cease to exist when their methods end. So, but objects cease to exist when they don't have a name anymore. Okay, so create a string object, create another string object, create a string reference variable pointing to one of the objects we already have, create another string object. Okay, make one of the arrows goes away. We made an arrow go away, but it didn't make the reference variable go away. When we made the arrow go away, the reference variable is still there. Now make another arrow go away, and that actually made an object go away because the object no longer had a name. Okay. Then we reused one of those names to make it a name for a different object. Okay. So that's the kind of thing we've been talking about. This is talking about objects and calling methods and objects. Now we want to start doing our own objects. We want to write objects. Okay. The idea of an object is to represent something in the real world. Like here, strings represent like words on a page. They represent something in the real world. Strings of letters that we consider, important for writing text. Okay. Here's another thing that's all over the place on this computer. Rectangles. If you look around, see there's rectangle there. This button is a rectangle. You can see there's rectangular images all over the place. There's all kinds of, if I open a folder, I get a rectangle. Inside the folder are lots of rectangles. There ought to be a way in a programming language to represent rectangles. Okay, and there are, but that's what we're going to do. We're going to design our own representation of a rectangle in Java. We're going to write a rectangle class. What we're going to do now is we're going to write we always pretty much took class names here that were just things like homework 1 and homework 3, or example of this or example of that. Now I'm going to write a class that represents a rectangle. Okay. And I want this class, for now I'm going to, for now we're going to not pay attention to the main method. We're going to pay attention to the methods that represent a rectangle. So we want to start thinking about what does it mean to write a rectangle class? Okay. Now, let me draw a picture of a rectangle so we can get point out a couple things that are important. Okay. Oops. Okay. My first thing, okay, I'm going to draw a coordinate system. So here's an XY coordinate system. Okay. So I'm going to think of that as an X coordinate and a Y coordinate. Okay. So every point in the plane has an X and a Y coordinate. Okay. Now I'm going to put a rectangle in the plane. And here's the rectangle essentially represented by some numbers. Okay. So like this, we want to think about how many different ways there are to represent a rectangle. So, for example, I could tell you where the lower left-hand corner of the rectangle is. So I could tell you this value here and this value here. Okay, that's a point. I can tell you that value there and that value there. That would tell you part of where the rectangle is. Then I could tell you where the upper right-hand corner is. I could tell you that number there and that number there. Okay, let me give these names. I'll call this number here XL for X lower, X on the left. Okay, and then I'll call this number here XR for X on the right. Okay, and I'll call this number YL for Y lower, and call this number YU for Y upper. Okay, then I could give you 4 numbers. I could describe the rectangle with 4 numbers. The X lower, comma, Y lower pair, and the X right, Y upper pair. Okay, those 4 numbers describe the rectangle. So they tell you where the lower left-hand corner is and where the upper right-hand corner is. And I'll put like a red dot there because I'm using that point there and that point there to represent I'm telling you where the lower left-hand corner and the upper left-hand corner is. Now that's one way to describe a rectangle. Here's another way to describe it. Instead of telling you those 4 numbers, I can tell you 4 other numbers. Okay, so for example, this rectangle, it has a width. Oops. See again. I can talk about the width of this rectangle. Whoops, I didn't draw that very well. This rectangle has a width. I'll call it W. Okay, and it's got a height. So I'll call that H. So there's a height. Okay. Now here's another way. Here's another 4 numbers that describe that rectangle. So down here, I could tell you where the lower left-hand corner is. So that would be XL, comma, YL. and I could give you the width, and I can give you the height. So I'm going to give you 4 numbers. Okay. Notice I'm giving you 4 numbers with 4 different numbers. Yep. It turns out in the real world of programming, when people want to describe rectangles, sometimes they do it this way by giving you 2 points that are opposite corners. Sometimes they do it this way of giving you 1 point and the length and height of it. Okay, here's another real common way to do it. A real common way to describe a rectangle is to use the upper left-hand corner and lower right-hand corner. Surprisingly enough, you can, so for example, I could use this point, I could use this point here and this point here. Okay, so now what would those points be? Now, if I tell you where the upper left-hand corner is and tell you where the lower right-hand corner is, there's only one rectangle that goes between those 2 points. So that would be 2 pairs of points, but one would be x, l, comma, y, u, and that would be the upper left-hand corner. The lower right-hand corner would be x, r, comma, y, l. Okay. Now, what this matters is when we go over here. Let me save this so I don't lose it. Okay. Here's a picture of what I mean by a rectangle. Okay. We're going to turn this into software idea. So over here in Java, we want to say, what is a rectangle? And we'll say that it's 4 numbers. So I'm going to go over here and I'm going to say a rectangle is double, 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 double. Okay, there's 4 numbers in a rectangle, but I have to decide which one of these I'm going to use. I have to decide, do I want to use lower left-hand corner and upper right-hand corner, or do I want to use upper left-hand corner, lower right-hand corner, or do I want to use one of these points and the width and the height? Okay, and for now, I'm going to pick one of them. I'm going to use the middle one, lower left-hand corner, width and height. Okay, so I'm going to say a rectangle is a variable XL for, and then I'm going to say this is lower left-hand corner. Okay, and I'm going to say it's going to be then it's going to be YL for YL. This is also in the lower left hand corner. So that's the X and Y coordinates of the lower left hand corner, XL, YL. Then width, that's self-explanatory, and height. Okay, and actually I probably don't even need the L here. Yeah, I could just say X and Y, and but remember, I'd have to remember for myself. I mean, X and Y is easier to read than XL, YL, but I have to remember that's the X and Y from the lower left-hand corner. Okay, that's my rectangle. Okay. Now, what I'm saying is this is the data that's going to be stored inside of a rectangle. Just like over here, what's a string? A string is some data. This is the data inside of the string. Okay. Over here, the rectangle has 4 pieces of data inside of it. Okay. Now, down here, I'm going to start creating rectangle objects. So this is going to be in this class, I'm going to have both this. I'm going to tell you what a rectangle is, and I'm going to make use of a rectangle. So down here, I can say rectangle. Now, rectangle R1, that's a rectangle variable. It is going to be I'm going to make it a new rectangle. Okay. Now, I'm not saying in here what X, Y, width, and height are. So let's see what happens if I run this. Okay, notice that I said I want a new rectangle, but there's nothing down here that says what X is, what Y is, what the width is, and what the height is. Okay, okay, we'll see. Let's execute that. Okay, so here's my rectangle object. Okay, right now it's filled in with all zeros. Okay, now that's, see, notice I'm at line 1 in something called this. I'm in the thing that's building this object. We're going to make this more precise as we go along, but right now I'm in a piece of code that's building the object. Okay, and now it's going to return a pointer to the object it just built. Okay, and now here's my R1 is the name of this rectangle. And I didn't say anything about what X, Y, W, and height, X, Y, width, and height are, and so they're all zeros. Okay, right? Now, I'd like to be able to create another rectangle. Now I want to create another rectangle. R2 equals new rectangle. And now I'm going to have two rectangle objects, but they look alike. You know, this rectangle object and this rectangle object are essentially rectangles that are, well, first of all, they're not very nice rectangles because their width and height are 0. They're sitting at this corner down here with no width and no height. So they're just 2 points sitting on top of each other. So that's not very useful. I need to be able to put something in my rectangle. Okay. So what I'm going to do is add what's called a special method in the object. I'm going to give this object a method called rectangle. Notice I'm defining rectangle objects, and I give the rectangle class a rectangle method. This is called the constructor. This is where I'm going to pass numbers for what X, Y, width, and height are. So I'm going to say that I have a double, which is the new X, and I can have a double, which is the new Y, and I have a double, which is the new width, and I have a double, which is the new height. So there's my method with 4 parameters, 1 for each of these numbers here. Okay. And then what I want to do is this number that comes in here, I want to store it in there so that the object remembers what its X value is. So I'm going to say that X equals new X. Now, this X is this guy up here. See, I look for an X variable in my code, and that says, well, this X is that one there. On the other hand, new X is that there. Notice how I kind of go backwards in my code to look for where variables are. So if I start with new X, I say, well, what variable is that? I go backwards until I hit new X, and that's this guy. On the other hand, if I go backwards looking for X, it's that guy there. Okay. And I'm going to keep doing this. The Y in the object gets its value from the new Y parameter in this constructor method. So what this is a constructor method. It constructs a new object. Okay, it constructs a new object. See, so this is what the new, see notice notice how this looked like a method call down here. And if we go back over here, this looked like a method call. See, I created a string object by saying new. I gave the name of the object I wanted to create, and then I used parentheses. So it looked like a constructor. It looked like a method call, a special kind of method call. So up here, I'm now writing that new kind of method, a special kind of method called a constructor. And then down here, I'm creating rectangle objects with it. Okay, now let me finish this. I need to say now that that's the width in the object I'm constructing. is new width. Oops, I made that capital. Oh yeah, new width and height equals new height. Okay. Now down here, I can give this rectangle 4 parameters. I can say, oh, it's based at 0, 0, but it has height 4 and width 5. And this one, I'm going to think of it as based at 1, 2 with height 1, width 1. Okay. Now, notice I'm not drawing rectangles. I'm thinking about representing rectangles. Some program that's drawing rectangles on the screen is going to be using my rectangle objects to remember where various rectangles on the screen are. Like this rectangle here would have in the screen coordinates some coordinate for the lower left-hand corner and a width and a height in the screen coordinates. And there is in Java a class that lets GUI programs like this keep track of rectangles. Okay, now let's see if this works. Okay, so visualize this. Okay, now here I'm going to create a rectangle variable and a rectangle object, and I'm going to make the variable refer to the object. Now this looks like I'm calling a method, and the visualizer treats it that way. The visualizer is going to jump up here to the rectangle constructor method and show it executing. Okay, so see, now we are in the constructor. Notice that it has this funny notation, says this. See, I'm constructing this object. Okay, here are my parameters, 0, 0, 4, 5. That was the lower left-hand corner. That's the width and the height. These numbers need to get copied into the object, into this object. This object's what I'm building. Okay, it's a weird use of the word this. You have to eventually get really used to this, using this as a reference, as a variable name. It's the dumbest thing they ever did was call this variable this, because the word this gets used too much in speaking English. Okay, and actually another programming language called this net variable self. Yeah, the object, that's itself. It's a little bit better. At least you don't use the word self in every other sentence. Okay, so when we talk about this variable this, we have to talk about this. So we're going to be talking about things like this, and the other this. And when we talk about this, we mean the this that's in this box. And when we talk about the other this, we'll talk about a this in another box. So it's very confusing, unfortunately. They should not have called this this. And they got the word this from C++. The C++ people are the ones who made the mistake of calling this variable this. And the Java people copied it because they wanted the Java language to look a fair amount like C++. So they copied even some of the bad ideas from C++. All right. So here, notice that I didn't declare the variable this. This is not one of my variables in my object. It's part of the Java language. Every object has a this variable. We'll see how we can use it in a minute. Every object has a this variable that points to itself. Okay, so that's why, notice I say it points to itself. That's why in some languages, it's actually, the variable is called self, not this. Okay, so now my code's going to start copying. Oh, okay, I clicked on the wrong button. Now my code's going to start copying these variables to these variables. Now, I shouldn't have used the value 0 because it looks like I'm just copying 0 to 0. So now we'll see what happened. 4 will get copied over here. And then 5 will get copied over here. Okay, now I filled in the rectangle object. So now the constructor is done doing its work. The constructor is going to return. Now it says return void. It's actually returning this. Yeah, I'm not sure why they didn't change that, because it's returning that arrow. So that it's going to return that arrow to R1. Okay. Okay. See, there's R1 pointing at that shiny new object. Okay. Now we're going to do the same thing again. Now we're calling, after we built R1, now we're going to build the object called R2. So now we're going to do this again, go up here into the constructor. Now we're building this object. See, now this points to this new object that's being built. Okay, so now copy the numbers 1, 2, 1, and 1. Okay, so I'm done copying the parameters of the constructor into the object. These are called the object fields. Okay, okay. These guys here are called the object fields. Okay, and these are the constructor's parameters. So over here, these are the object fields. These are the constructor parameters. And I'm just doing kind of the obvious, copying that constructor parameter into that field, copying that constructor parameter into that field. Okay. Now the constructor is ready to return. It's going to return that arrow to R2. Okay. So now I got my two objects. Okay. Now I haven't done anything with them. Usually with objects, what we do next, okay, now let's see. Remember, these are the object fields. That's one of our important words. The fields of an object. Okay, this is constructor. Constructor is an important word. So every object needs a constructor to build it. Objects need fields to hold the data in an object. Okay. Now we need to give this object some methods because it doesn't do anything yet. So let's give it a method that will move a rectangle. Okay, because over here, if you think about it, even Paint's a really lousy drawing program. I can't actually move a rectangle after I've drawn it. But if I was using a better Paint program, you could move a rectangle around. After you've drawn a rectangle, you could move it around. I should stop using Paint and start using a better drawing program because one of the problems with Paint is that you can't move anything. Once you've drawn something, it's just there on the page and it can't be moved. It's like writing in ink on a piece of paper. Once you've drawn it, it's fixed. But good drawing programs, they let you move things around. Okay. I'm trying to remember the name of a good drawing program on the internet. I'm trying to remember the ones I. Does anybody have? See this? I think that's a good one. No. Oh, I'm trying to think. There's one I used to use a lot, and I can't remember the name of it. A real simple online. Okay, actually, I should give online drawing program. Huh, I wonder if the ones I used to use are gone. Let me just try Sketchpad. Now, where's rectangles in here? See, it's trouble. That's why some of these programs are, see, it's drawing I wanted to draw rectangles. Where would I look for rectangles? See, trouble with these. Does anybody have any suggestion? Where would you? Does anybody remember offhand, like where you would usually find like a new, like be able to draw a rectangle and move it around? Huh? Should be here. Okay. Yeah, I want, we should be able to move our rectangle. So here's how we're going to do it. We're going to create a method. Okay. So we're going to write a method, a public. Now it's not, this is our first method. It's not going to have the word static in it. Okay. Because we're going to write a method that is not a static. It's going to be a method that moves a rectangle. So it's going to be a method that doesn't return anything. And I'm going to call it move. Okay. I'm going to call it move by. Okay. Okay, move by is going to take two parameters, and a double x and a double y. Okay, so it's going to move by x and move by y. What does that mean? That means it's going to take the x that's in. Oh, I've got two x's now. I got a problem. I got this x up here and this x over here. And I really want to say I want the x that's up here. I want it equal to itself plus this x. Okay, notice I want this x to be equal to its former value added by this, because this is going to move it. Okay, now how do I refer to this x instead of this x? Well, the answer is that pronoun this. This x is the x that belongs to the object. So I can go down here and use that word this that we saw that was in the constructor. This x is this x, the x of the object. Okay, so I want this, and then I want this one to be this x. But this x is this x. Because I didn't put the this in front of it, it's the x that's the parameter. Okay, so this is where things start getting tricky in Java programming. Okay, now I could have solved this problem by giving this guy a different name, but that isn't solving the problem, that's avoiding the problem, because you're going to see people use this style of programming all the time. I want to move x, I want to change x, move x by a certain amount, and that certain amount is an x coordinate. I want to move horizontally. So then I've got this x up here and this x over here. So I can give this x a more precise name by calling it this x. Same with the y. This y, I want to change it to be its current value plus the amount to move by. Okay. Now down here, I can start doing the following. I can say my rectangle R1, I want to move by the amount. Okay, I'm going to move it up 3 units and to the left 2 units. See, I can use a negative number in the how much I move by. Oh, I'm sorry. This is move to the right 3 units and move down 2 units. Now, I won't see any movement because I'm just changing numbers, but the rectangle, what it represented was being moved. Okay. Now let's see if this works. Okay. So step through the code that builds the rectangles. Okay. Now we've built our rectangles. Now I'm going to call on this method. I'm sorry, on this object. I'm calling my method on R1. Okay. So watch it. I go forward. Okay. Now I'm in the method, move by. Okay. Notice that the this is pointing to what R1 pointed at. See, we called it on R1. When we get in here, we're in here with this being the same object that R1 was pointing at. So we're executing on this object. Okay. Now I go over here and I execute line 20. Line 20 says take x is this guy, this x is this guy. Okay. This x is over here. So notice that I've got an x variable here and an x variable here. Just like down over here, I have an x variable here and an x variable here. X with the this in front of it. Well, there's the this in the picture. Follow the arrow, and then there's the x. You can think of this as like the dot. This dot x. This dot x. but the dot is actually the arrow. And a lot of people read these dots. Now you know, a lot of people read these dots as arrows. Okay, follow this to the X. Follow the arrow to X. Okay, and then what do I do with that X? I add this X to it. So I will be taking 3 plus 0, and then I store the result in this X. So first I go on the right-hand side here, and I say this X added to X. This X added to X, and that gives me 3, and then store it in this X. So I'm going to end up with 3 here. Okay. Then I move down to the next line, which does the same thing with Y. I'm going to take this Y, add it to, I'm going to take this Y, add it to the Y parameter, and then store the result in this Y. So I'm going to read this Y, which is 0, add it to the parameter Y, which is -2, get -2 when I add them, and store the result in there. Okay, so that's going to make that guy -2. Notice if I'm moving a rectangle, I'm not changing anything about its height and width. See, there's no reason to change the height and width when I move something. Okay, then I'm returning. There's nothing to return. I did the work on this object. So this method was void. It doesn't give you back an answer. Its answer is in the thing it was working on. We saw this stuff with arrays. When we wrote our methods on arrays, if we go back here, just real quick, when we wrote all these methods on arrays, remember we saw that some array methods didn't return anything. Okay, they would, like this one here. See, it did its work in place. Remember, that was the increment in place. So the method modified what was in that array, and it didn't return anything. The methods we're writing now are a lot like this method. They modify something without returning anything. Okay, so over here now we have a move method on a rectangle. So moving a rectangle means changing its X and Y coordinate, but we do the work inside the rectangle itself. We don't return anything. In a minute, we'll see a method we'll see a method on a rectangle that would return something. Okay. Okay. Now we're done with doing the move. Okay. So now this object's been moved. Okay. Now okay. Now let's go back and do some. Let's do 2 more methods. Another motion of Here's another idea how you would move a rectangle. I could move to a certain place. Instead of moving a rectangle by an amount, I can move it to a certain location. So I'm going to move it to double X, double Y. Okay. But now the idea would be this X equals X. I just move to that new variable. See, now I'm saying that's the new location for the lower left-hand corner. So move the lower left-hand corner to that X. Notice the difference in how I wrote it. This updates this adds this offset to what was there. This just says this is the new location. Then I can say this Y equals Y. Okay. Okay, there's a move to. Okay. Now, here's a method that would return something. It wouldn't be unusual to say, I want to know what the area of a rectangle is. So let a rectangle return a double that's the area of the rectangle. Now, area doesn't need any parameters. All the information for computing the area of a rectangle is in here. So notice that this method doesn't need any input information, and it provides an answer. These needed input, but they didn't provide an answer because the work they did was on the object itself. Now, area is easy. It's going to return the width times the height. Okay, that's the area of a rectangle. Okay. Now, notice we're writing interesting methods on our We're representing different things about the object. Like what if you want to think about rectangles, you moving it around would be what you do in like a graphics program. Now, computing the area might be what you would need to do if you were designing like an architectural program, and you need to know like a wall would be a rectangle. Might need to know what the area of the wall was, so you could purchase enough paint for it or purchase enough wallpaper for it. So you use rectangles to represent things in different, the rectangle class can be used to represent rectangles in all kinds of different situations. And you could do graphical like things to rectangles, move them around. You could do math like things to rectangles, like compute their area. Okay. Now let's play around with this a little bit more. So go down here. I'm going to move R2. I'm going to move it to the location, say 5, 10. Okay, that's a move to. Okay, and then I want to know what, say, double A equals R2 dot area. Okay. Notice that if since area returns an answer, I need to store it somewhere so I can see what it is. Okay. All right. So just let's step through this. We're building R1. Okay. We're in the process now. See, we came from line 40 in main. So we're building R1. Okay. There's putting the values of R1 in the R1, what's going to be the R1 object. Okay, there's our R1 object. Now let's go build the R2 object. Okay, we put these values in the what's going to be the R2 object. Okay, now we got the R1 and the R2 object. Okay, now tell the R1 object to move by the amount 3, -2. Okay. Okay, R1 is moved. Now we're going to tell R2 to move to 5, 10, not move by, not move 5 units to the right and 10 units up. That would be move by, but move to the location where its lower left-hand corner is at 5, 10. Okay, so move to. Now that just takes 5 and puts it in here on top of that number, and takes 10 and puts it in here on top of that number. Okay, so now we've moved to 5, 10. Okay, now let's figure out what the area of R2 is. Okay, okay, area is going to be returned width times height. Now, width is that variable up there. See? Now, if I wanted to, I could go, well, okay. Okay, width is 1. Now, sometimes when you read this, there's no parameter here. So notice that you're used to when you have a method, every method you've written so far in the class, the variables in the method were the parameters. This can be confusing. A lot of people like to always write the word this there to remind themselves that this is the variable in the object. Okay, you don't have to, and it's kind of a 6 of one, half dozen of the other thing. A lot of people like to write them because they think it makes the code more readable. Other people think it actually clutters up the code. Some people think it's too much writing and makes the code cluttered. Some people think it makes the code easier to read. So you could even mix things up. This width times height. Well, height is this height here. Okay. Now, it's important to think that way because if you go over here and you step through this code, notice that there's multiple widths. Yeah, the word width, like here, it really is the width in this object. When you call this method, you have to remember that when you call this method, you're distinguishing between the width in this, like here, this width is that width because this is pointing at that object. This width is just is sitting in some other object. When you're inside this object, you actually have no access to any other object. That's one of the important things about object-oriented programming is you can only, when you're inside one of these methods, you can only access the method that you have an arrow to, okay? You can actually have an arrow to other methods. Like here's an interesting problem. Let's do an interesting case. If I have two rectangles, I could ask if they overlap. Okay, so if you give me two rectangles, the two rectangles could possibly overlap. Okay, let me use a different color. Let me okay, right. Now we're modeling a rectangle by its lower left-hand corner. Whoops. Oh, I didn't change blue. Okay. Here's a rectangle. Oh, okay. Now remember, a rectangle is modeled by its what? Oh, I know what I'm doing. I'm waiting. I'm changing color too soon. Ah, okay. Paint's not a very good program. Okay. Uh, okay. Now I have to move away from the rectangle. Now I can change the color. Then, we're using the lower left-hand corner and upper right-hand corner and the width and height to say what a rectangle is. Let's write a method that tells us whether two rectangles are overlapping or not overlapping. Let's try to use this picture to see if we can figure out what the code would look like. So this would be useful like in a program like this. If rectangles are overlapping, you have to know, then another thing you have to figure out is in a real sophisticated paint program, like which one's above the other. Because if you fill in this rectangle, it would have to cover up part of the other one. Okay? But then if you filled in this rectangle, it would cover up part of that one. So you kind of have to also keep track of whether they're overlapping and which one's in front. Okay, so I want to write a method. I'm going to call it overlapping. Now, it's going to return a Boolean. Now, what's going to happen is there's going to be two rectangles. I'm going to call overlapping, let's say on the black rectangle, and I'm going to give it a parameter that's another rectangle, R, that's the other rectangle. So notice that there's, now some people like to call this that, because there's going to be two rectangles, this and that. This rectangle and that rectangle. This rectangle will be the rectangle I call the method on. So down here I would say Boolean B1 equals overlapping. I'm going to ask, is R1 overlapping R2? But I could also go Boolean B2 equal, is R2 overlapping with R1? Now, these give the same answer. If R1 and R2 overlap, they have the same answer. But here, R1 is this rectangle and R2 is that rectangle. Here, R2 is this rectangle and R1 is that rectangle. Up here, there'll be a this and a that rectangle. So, okay, so what would my code look like? Okay, now, oops. It's a little bit tricky. Now, what makes two rectangles overlap? Okay, I have to figure out. Let's see if there's an easy way to figure out if two rectangles overlap. They can overlap in complicated ways. Okay, if they overlap in complicated ways, because sometimes the rectangle could overlap over here, or the blue rectangle could be completely inside of the black rectangle. The blue rectangle could be completely outside the black one. So you have to, you have to think of some logic that would tell you for sure that the two rectangles overlap. Trying to remember if there's an easy way. Anybody have an idea? Like, is there anybody see a simple thing that would test whether two rectangles are overlapping or not? I can think of a complicated way. Okay. If the okay, take the blue rectangle. If it overlaps the black rectangle, one of the four corners of the blue rectangle has to be inside the black rectangle. Okay. One of its four corners needs to be inside the black rectangle. I don't know which one of the four it could be, because it could be a picture like this where it's the lower left-hand corner. The blue rectangle could be over here. The blue rectangle could be like this, where all four corners are inside the black rectangle. The blue rectangle could look like this, where two of its four corners are inside the black rectangle. The blue rectangle could look like this, where it's its upper right-hand corner that's inside the black rectangle. But one of its four corners has to be inside the black rectangle. So here's how I'm going to do this. I'm going to write a helper method that might be kind of useful. Okay. So first, let me write a helper method. Public Boolean inside double x double y. Is this point inside of this rectangle? This one's not too hard to write. If I just give you a point, so now I'm just going to give you a point. The point's got an x and a y coordinate. So I give you a point, and you want to know if the x, you want to know if the point is inside the black rectangle. So the x coordinate has to be between x sub L and x sub L plus width. Okay, so we want the x coordinate of we want this x, I'm sorry, we want this x, the x we're given, okay? I'm going to call that px for point x and point y. Notice that here calling it x was just b. I want the x of the point and the y of the point, okay? So we want px. That's this point, that's this number down here. This number down here would be, we'll call that px. Okay, and this number over here, we'll call that py. Okay, we want to know that px is between the lower left-hand corner x and the lower right-hand corner x. Is it between? So we would need px is larger than this dot x, and px is less than or equal to this dot x plus width. Okay, because remember this is over here. This is this dot x. This dot x is this lower at this left edge. So we want px to be to the right of this left edge and to the left of this right edge. And this edge is this guy plus width. Notice without the picture, I would have a hard time writing this code. I need a picture. I'm doing this example because I want you to realize that a lot of times when you write code, you need a picture to help you write the code. Don't think you can just sit and write code. Nobody can. Everybody draws pictures when they're writing code because the code represents something, and usually a picture of that something will help you figure it out. Okay, so I'm kind of over here sketching out what I need. I'm given px and py. That's the point. I want to know if it's inside the rectangle. Is it to the right of the left edge and to the left of the right edge? So that's this guy. Is it, I can put some parentheses. Is it, whoop. This says I'm to the right of the left edge and to the left of the right edge. Then I need to say, and I have to start worrying about the y coordinates. I need py being larger than this y. This is remember the xy of the rectangle is this lower left hand corner. So I need this y. I need it larger than, okay, no, I need py. See, I need py greater than this y. I need py greater than this y. Okay. And one more case, I need py less than this y plus height. So I need py less than this y plus height. Okay. Now this is getting too long and hard to read. So here's what I'm going to do. I'm going to make this a little bit easier to read by making it in a bunch of lines. So I'm going to write it this way. Here's a nice way to say and. Okay. Let's see. Okay. Now notice that the thises can kind of clutter things up. So again, it's do you want the, like if I wanted to, I could write, well, that's this width, and this is this height. Okay. All right. This x is less, well, px is to the right of this x. Px is to the left of this x plus this width. This y, py is above this y, and py is below this y plus this height. Now, yeah, all the this is in here probably, this is why people don't like the this is. They kind of do maybe sometimes clutter things up. Now, this is what I want to, this is my answer. Notice I'm using the word this a lot. This is the answer. This is the Boolean that answers my question. So what I want to do here is just say return this whole thing here. Okay. So I'm going to do it this way. Make it, I'm going to return that guy. Sometimes finding a way to format your code so it's readable can be real important. So there, I'm going to return, let's see, and then I need my closing brace. Return, this x is less than px, and this x plus width is less, return px is to the right of the left edge, px is to the left of the right edge, py is above the bottom edge, py is below the top edge. If all those are true, you're inside. Okay. Now, what about overlapping? Remember, we said that this rectangle is overlapping that rectangle if one of its corners is inside of this rectangle. So over here, I need to ask 4 questions. I need the 4 corners of that rectangle. And for each corner of that rectangle, I need to ask if it's inside of this rectangle. Okay, so I'm going to return 4 questions. Okay, so I'm going to return, I'll call it corner 1 is, so I'll say this dot inside. A little bit tricky to write. Okay, this dot inside is this one. I'm asking if something's inside. So I'm going to call this corner 1. Corner 1 is going to be one of the 4 corners of that rectangle. I'll define it later. So return corner 1 is inside this, or corner 2 is inside this, or corner 3 is inside this, or corner 4 is inside this. Okay, again, now I'll do the same kind of trick to make this a little bit more readable. I'm returning that kind of, okay. Now what's left is to say what the C1, C2, C3, and C4 are. Now, there are really two numbers. There's two numbers here. Corner, I want two numbers for that corner. Okay, so that's a C corner 1 X, corner 1 Y. That's what the two, now I'll define these in a second. Then I need a corner 2 X and a corner 2 Y. Notice I have to come up with names for a lot of ideas. So I'm letting you see like how I think when I'm trying to write code. And it's sort of, it's a kind of a messy thing. You block out pieces of the code. Like I thought in terms of, first there was, I need to know that I'm inside, I have 4 corners, and I need to know whether one of the corners or the other, I want to know if one of the 4 corners is inside the rectangle. And I just call them C1, C2, C3, C4. But the method inside needs the two numbers that make up the corner. So now I'm going to say, well, what I need are these variables, corner 3x and corner 3y. And I need a corner 4x and a corner 4y. Right? Now that means up here I need to start declaring them now. Double corner 1x. I'll write a formula for it in a second. I'm going to need 8 of these numbers. Corner 1x, corner 1y, corner 2x, corner 2y, corner 3x, corner 3y, corner 4x. Programming can be kind of tedious, and you're seeing how, like, when you write code, sometimes it gets tedious. You keep just kind of doing the same thing over and over again. Okay, so now I'm going to have to give these guys values. Once I give each one of these a value, I'll be done. But I'll have to go back to my picture to figure out what would be the right thing for each of these. So now I'm in the blue rectangle, and I want to do its 4 corners. Now, 2 of the corners I get for free. Well, actually, one of the corners I get for free. I'll call this corner 1. So I'm going to do corner 1, corner 2, corner 3, corner 4. I can do it any order I want. Corner 1 is the x and y coordinates of that point. Okay. So corner 1 is that point's x coordinate, and corner 1 is the y coordinate. Corner 1 is that rectangle's y coordinate. Remember, I have this and that. Okay. I want to know if that corner is in this rectangle. See, there's that rectangle and this rectangle. I'm making the black one the this, and I'm making the blue one the that. Okay. So I'm thinking of the blue one as that rectangle. Okay. That corner there, I want to know if it's inside this rectangle. So corner 1 will be that x and that y. Okay, now what's going to be corner 2 up here of that rectangle? We'll have the same x, but the y coordinate will have the height added to it. So it'll be that x, and this will be that y plus that height. Okay. Okay, now I move to the next rectangle, next corner. Okay, corner 1, corner 2, in corner 3, when I get to corner 3, its x coordinate is well, okay, corner 3 is this guy's x coordinate plus width, and its y coordinate is this guy's y coordinate plus height. Okay, so for corner 3, I have to add height and width to, so it's that x plus width, that width. I don't have any choice about the that's. I can't, if I drop the word that there, this is then this width. If you drop the that, it defaults to this. So I got to make sure that I write the that there. Okay, that width. And then this one will be that y plus that height. That y plus that height. Okay, so now I've done corner 1, corner 2, corner 3. Okay, corner 4. Okay, it's going to have the height of this corner here. So corner 4, will just be that y, but it'll be that x plus that width. Okay. Okay. So there's overlapping with inside as a helper method. See, now this is the kind of thing that would be a homework assignment. This is a good example of a nice little example of what you when you give you homework assignments with this object-oriented programming. This would be a good example, figuring out whether two rectangles overlap or not. It's not hard, but it's not easy either. This is not the only way to do it. I did it in a way with that took a lot of lines of code. Probably somebody can come up with maybe a slightly more clever way, but my idea is, yeah, I'll document it. I'll write a comment. The rectangles overlap if if at least one corner of that is inside this. Okay, so the rectangles overlap if at least one corner of that is inside this. Okay, so here's the 4 corners of that, and then I check if one of the 4 corners of that is inside this. Okay, is inside this. All right, now let's see if this compiles. I don't think I made any typing errors. Okay, so I didn't make any typing errors. Okay, but we have to test it. But we run out of time, so we'll come back to this next week. We'll keep playing around with. Notice how I've written quite a bit of code already. Okay, so we'll come back to this example. The rectangle example is a real famous example. Almost every textbook uses rectangle as a first example of let's write a class and create objects that model something. Okay, and what we want to model are the ability to draw rectangles on the screen. Okay, so we're just modeling the rectangles. We're not drawing the rectangles. We're not writing a graphics program, but we're giving a tool that a graphics program might need. A graphics program is going to need a rectangle class. It's going to need a circle class and an oval class and a point class so they can keep track of things on the screen. It's going to need a line class. So it's going to need classes for representing all this. And then someplace in the program is going to be the stuff that takes a rectangle object and draws its picture on the screen. But that's beyond the scope of this class. But that's part of much later when you learn graphics. Like how would you eventually actually turn a rectangle object into pixels on the screen? Okay, all right, so we'll quit there. Okay, I'll put this example up on the course website and keep on reading. See, we've talked now a little bit about these writing constructors, designing classes. This is what we've been talking about. This idea of writing constructors and designing classes. Okay, all right. So, anybody got any last second question? Any last second question? If you got a question about the homework assignment, we spent Tuesday, talk about the homework assignment. Okay, if you have questions about the homework assignment, send me email or so definitely start looking at the homework assignment. And if you have questions about them, if you have if you have a question at the beginning of class, we could also look at the homework assignment. Next week, if somebody's got a question about the homework assignment, we could do that, say, at the beginning of class. Okay, and then we'll continue playing around with examples like this. We're going to write our own classes for a while. Okay, all right. So any last second question? Okay, so I'm going to stop sharing. Have a good weekend. Bye bye.